Hi everyone, this chapter we are going to look at atoms, elements, molecules, compounds and mixtures. Okay, so essentially when we talk about all these items over here, we have a general name for them called matter. M-A-T-T-E-R. Okay, you will probably have learned that matter is anything that have mass and occupy space. So when we classify matter, we group them under pure substance and mixtures. Okay, anything that is pure, we have your elements and we have your compound. And then anything that's a mixture, we have solution and suspension. Okay, solution and suspension will be taught in detail in the next chapter. Okay, so what is atoms, elements and molecules? Okay, atoms, it is the simplest unit of an element. Okay, elements are the building blocks of matter. So what does this mean? So this means that, for example, in living things, the simplest unit is your living cell, right? But in anything that have mass and occupy space, right, the simplest unit is the atom. So if we look at anything that have mass and occupy space under a very high definition microscope, it will all appear something like this. Okay, so individual balls that you see over here, that is an atom of the element. Okay. Okay, next part we are going to look at is the elements. Okay. Elements are shown in the periodic table according to their proton number. Okay, so for all of you who have the book with us, okay, please flip to the last page of the book and then you will get your periodic table. Okay, so let me flip to the last page, yeah? Okay, so this is the periodic table. Be very familiar with the first 20 elements. Okay, first 20 elements is very important. Alright, so this is element number 1 over here, all the way until at least element number 20, calcium. Okay, so elements in the periodic table are arranged according to proton number. So if you look at the periodic table, or the top number over here, right, all the top number that you see, if you look at the key says the top number is the proton or the atomic number. So proton number is the top number over here, and then they are arranged according to proton number, meaning to say, you can see in running order, we have element number 1, 2, 3, 4, 5, 6, 7, all the way until 19 and element number 20, and it will continue on. Okay, capital letter represents one element. So the next, in the key, the next thing that we have is the atomic symbol. So the atomic symbol in this case, for example, your hydrogen, right, the symbol is a capital H. So capital H represents one element. In this case, the element is hydrogen. Okay, if you look across your periodic table, some of the symbols will have two letters. For example, element number 13, aluminium, the letter is Al, capital A and small l, right? So same thing, now that there's only one capital letter and one small letter, right? This one capital letter over here represents a single element, aluminium. Okay, next point, element symbols is usually the first alphabet. Okay, so what do we mean by that? Means, so same thing, if you look at the name of the element, which is aluminium, the symbol itself, we represent it as Al. Right, if the name is hydrogen, the symbol is just the first letter of hydrogen, which is the capital H. Why is it that some of the elements are not just one single capital letter? Is because, for example, if we have carbon over here, element number 6 is carbon, starts with C, so it is represented by capital C. Okay, but if we look at the next element, number 24, chromium. Chromium also starts with C. So if we keep using the C, it's repetitive. So some elements, instead of having just the starting letter as the symbol, we represent two letters. Okay, elements are pure substance. They are made up of one type of atom. Okay, one type of atom, what does it mean? It means that the elements have the same size, same color, same number of subatomic particles. Okay, subatomic particles, we will again be looking at it in detail in another chapter. Okay, so for example, if you look at aluminium metal piece under the microscope, right, all the individual balls that you see, they will have the same size. Okay, you cannot have some that is small, some that is big. This one will not be aluminium because the type is not the same. Okay, elements cannot be broken down into simpler substance by chemical methods. Okay, so what is chemical methods? Chemical methods, let me write it here. Okay, for now we can take chemical methods as high heat, electricity. Okay, and then under these chemical methods where energy is actually given, these elements, because they are the simplest unit, we cannot actually break them down further into other substances. Okay, elements are pure substance, they have unique properties. So they have unique physical properties, they also have unique chemical properties. Okay, unique physical properties means they have fixed melting point, fixed boiling point, and then fixed density. Okay, there's an imaginary staircase from boron. Left of the staircase are metals, right of the staircase are non-metals. Okay, so the imaginary staircase over here is from boron, element number 5. Right, from boron we can draw a staircase down. Okay, just keep zigzagging all the way down. Yeah, so left of the staircase, all these elements over on the left side, these are all metals. And then all these elements on the right side, these are all non-metals. Okay, there are 2 liquids at room temperature and pressure. So among all the elements in your periodic table, 2 of them are liquid at the standard room temperature and pressure. So we have to know which 2 are liquid. So we have over here element number 80, mercury. This is liquid. Okay, as well as element bromine number 35. This is also liquid. Okay, the rest, because most of them, if you look at the elements from here onwards all the way until here, most of them are metals. So most of them are solid at room temperature. Okay, there are a few gases, likewise we have to know their state, which of them are gases. Okay, so the gases ones are over here. We have your hydrogen gas, nitrogen gas, oxygen gas, fluorine, chlorine. Okay, these circled ones in blue are gases, as well as all the elements under group 0 over here, group 0. These are all your noble gases. Okay, and then how many elements are there? So if we look at some of the chemical formulas of some of the compounds that are around us, for example, sodium chloride, when you see NaCl, right, first identify the capital letter. Since there are 2 capital letters, there are 2 elements inside them. Okay, for example, if you see C6H12O6, right, there is 3 elements. We have element, because there are 3 capital letters, you have your carbon, hydrogen, oxygen. Okay, and then there's actually 6 carbon, 12 hydrogen, and 6 oxygen.